H is equal to 2t cos theta divided by r rho g is the formula for determining the height of capillarity. We know the application of Pascal's law helps in hydraulic lift and hydraulic brakes. So this is hydraulic lift, which means we need to think about Pascal's law now. The diameter of the heel is 1 centimeter, that is nothing but 1 into 10 power minus 2 meter. Hello everyone, welcome to session 6 of chapter 10, Mechanical Properties of Fluids. This is Swati from Department of Physics, Vidhyaashram Pre-University College, the Temple of Excellence, Mysuru. Till session 5, we have discussed about the theory part of mechanical properties of fluids. In today's session, we are going to discuss about the numericals. So in this chapter, we have come across certain formulae. Let us have a quick recap of all those. So we have pressure is equal to force divided by unit area, and the unit for pressure is Newton per meter square or Pascal. Pressure inside a liquid is given by the formula P is equal to rho GH, where rho is the density of the liquid, G is acceleration due to gravity, and H is the height of the liquid column. And we also have P is equal to PA plus rho GH, which is nothing but the gauge pressure. So it is equal to atmospheric pressure plus the actual pressure at that point. And we also have equation of continuity for a streamline flow, that is AV equals constant, where A is the area of cross section of the pipe in which the liquid is flowing and V is the velocity. This equation of continuity can also be given as A1 V1 is equal to A2 V2 for different cross-sectional area of a pipe where the liquid is entering and coming out. And also we have Reynolds number, it is denoted by Re, which is given by rho Vd divided by eta, where eta is the coefficient of viscosity. We have discussed about Bernoulli's principle, which is nothing but the sum of pressure plus potential energy per unit volume plus kinetic energy per unit volume, which remains constant. And also we have V is equal to root of 2gh, which is nothing but the speed of efflux, which is given by Torricellis law. And F is equal to 6 pi eta Rv is nothing but the Stokes law. The force is equal to 6 pi eta Rv. And F is equal to eta A dV divided by dx is also what we have discussed in the theory part, and H is equal to 2t cos theta divided by r rho g is the formula for determining the height of capillarity. So from all these information, we have again quickly recapped what we have come across in this chapter. So today we are going to solve the first question, that is, in a car lift, compressed air exerts a force F1 on a small piston having a radius of 5 centimeter. This pressure is transmitted to a second piston of radius 10 centimeter. If the mass of the car to be lifted is 1350 kg weight, calculate F1, force we have to calculate. What is the pressure necessary to accomplish this task? See, in this task, this problem, they are saying that we have two pistons, one is of radius 5 centimeter, the other one is of radius 10 centimeter. Here, the compressed air exerts a force on a small piston here of radius 5 centimeter, and this pressure again in turns, it will again exert a pressure on the second piston of radius 10 centimeter. If the mass of the car to be lifted is 1350 kg weight, what is F1? What is the force we have to find out? And even we have to find out what is the pressure necessary to complete this task. So we know the application of Pascal's law helps in hydraulic lift and hydraulic brakes. So this is hydraulic lift, which means we need to think about Pascal's law now. So let us solve this problem with the help of Pascal's law. So before that, let us write what are the given things. Here we need to find out the force F1, and the radius of the first piston is given, that is 5 centimeter, which can be written as 5 into 10 power minus 2 meter, because meter is the standard unit. And force F2 is 1350 kg weight, but force unit is Newton, it is not kg weight. We need to write it in Newton. So to convert that kg weight into Newton, we need to multiply with 9.8. So 1350 into 9.8 Newton, and the radius of the second piston is given, that is 10 centimeter, which can be written as 10 into 10 power minus 2 meter. So from Pascal's law, we know that F1 divided by A1 is equal to F2 divided by A2. We have discussed in detail in the study of Pascal's law in a theory slides. Or we have to find out F1 here. So let us now rearrange the terms. So we can just multiply this to the numerator, and we will get F1 is equal to A1 divided by A2 into F2. Now A is nothing but area. So area of cross section, area is nothing but pi r square. So here we have A1, so we can write it as pi r1 square divided by A2, again area, pi r2 square into F2. So pi and pi can get cancelled. Radius of two pistons are different. Pi value is same, so it can get cancelled. F2 value is different. R1, R2 values are different. So let us now substitute all. We have F1 is equal to R1 square divided by R2 square into F2. R1 is 5 centimeter. It can be written as 5 into 10 power minus 2 meter. Since it is R1 square, 5 into 10 power minus 2 the whole square divided by 10 into 10 power minus 2 the whole square. So you square this, 5 into 5, that is 25, 10 into 10, that is 100. So multiplying F2 value with this, that is 1350 into 9.8, we will get 3307.5 Newton. So that is force. Here we have got the value of force, that is our first task. The second task is to find the pressure. What is the pressure required to accomplish this task was the question. So pressure formula is P is equal to F divided by A. We got the value of F1, that is 3307.5. So substitute the same, you will get 3307.5 divided by A1, area is nothing but pi r1 square, and pi value is 3.14. R1 value is 5 centimeters, so 5 into 10 power minus 2 the whole square. So simplifying this, we will get 4.210 into 10 power 5 Pascal. Here units are very important. Since we are finding the pressure, the unit of pressure is Pascal. So we have air is streaming past a horizontal aeroplane wing such that its speed is 120 meter per second over the upper surface and 90 meter per second at the lower surface. If the density of air is 1.3 kg per meter cube, find the difference in pressure between the top and bottom of the wing if the wing is 10 meter long and has an average width of 2 meter. Calculate the gross lift of the wing. So here we have to use Bernoulli's principle. Looking at the question only, we will come to know that which formula we have to apply, which is the concept it is related to. Yes, it is related to Bernoulli's principle. Let us now write the given data. They have given the density is 1.3 kg per meter cube. So density is 1.3 kg per meter cube, and the velocity V1 is 90 meter per second and V2 is 120 meter per second. So from Bernoulli's theorem, for a horizontal flow, we know P1 minus P2, that is the pressure at one end to the pressure at the other end. So pressure at one end is denoted by P1, pressure at the other end is given by P2. For a horizontal flow, we know, let us write the Bernoulli's principle for both the ends, that is sum of pressure plus rho GH, that is the potential energy per unit volume, and half rho V1 square, the kinetic energy per unit volume, is equal to P2 plus again rho GH plus half rho V2 square. Because we know when the flight is flying on a horizontal plane, the height will be same. So you can cancel these two and we remain with P1. Bring this term to the other side. We know P1 minus P2 is equal to half rho common, and we remain with V2 square minus V1 square. So that is what we have applied here. But we have all the data for this formula. Let us now find out. We have to find out the pressure difference between the top and the bottom layer, that is P1 minus P2, and which is equal to half into rho value is 1.3, V2 square is 120 square minus V1 square is 90 square, because they have given it is velocity 90 meter per second square and 120 meter per second square in the question itself. So let us substitute all. We get 1 divided by 2 into 1.3 into 120 square minus 90 square. So solving that, we will get 4.095 into 10 power 3 Newton per meter square, and we have to even find out the lift force on the wing. So force is equal to pressure into area, because we know pressure is equal to force divided by area. To find force, you have to multiply these two. So force is equal to pressure into area. What is the pressure? We have calculated 4.095 into 10 power 3, and area is 10 into 2. Because in the question they have given that the length is 10 meter and it is having a width of 2 meters. So the area is nothing but length into breadth. So 10 into 2, which is nothing but 20. Multiplying this, we will get 8.190 into 10 power 4 Newton. Since we are calculating lift force, the unit is Newton, which is very important to understand. Next question, calculate the height to which water will rise in capillary tube of radius 0.4 millimeter if surface tension of water is 0.072 Newton per meter and density of water is 10 power 3 kg per meter cube. Here we have to find the height of capillary rise. The height of capillary rise means you have to think about the formula H. So let us now write the given things. The radius of the tube is given, that is 0.4 millimeter. Let us write it in meters. That is 0.4 into 10 power minus 3 meters, and that can be written as 0.0004 meters. And the surface tension is given 0.072 Newton per meter. The density of water is 10 power 3 kg per meter cube, which is nothing but 10 power 3 means it is nothing but 1000 kg per meter cube. Now we have to find the height of water in the capillary tube, that is H equals 2T divided by rho gr. Let us now substitute all the values what we have. So 2 into 0.072 divided by rho is nothing but the density. So 1000 into g value is 9.8 into the radius is 0.0004, and we get the value 0.0367 after simplification. This can also be written as 3.67 centimeters. So this is the height of the capillary rise in the tube. So if you know the formula, it is so simple to get the solutions for all these problems. So next we have a 50 kg girl wearing high heel shoes balances on a single heel. The heel is circular with a diameter of 1 centimeter. What is the pressure exerted on the horizontal floor? So the question is so clear that a girl is having a weight of 50 kg wearing a heel of a circular shape with a diameter of 1 centimeter. What is the pressure that exerted on the horizontal floor? We have to find out. So mass of the girl, that is 50 kg, force on the heel, that is F is equal to mg. So what is m? 50 into 9.8, that is 490 Newton. Here to calculate pressure we need force. So from the data what we have, we can calculate force. So we get 490 Newton. The diameter of the heel is 1 centimeter, that is nothing but 1 into 10 power minus 2 meter. So area of the heel, it is nothing but pi d square by 4, because area is nothing but pi r square by 2, or it can be written as pi d square divided by 4, because we know diameter is equal to twice the radius, or radius is equal to diameter divided by 2. So we can even write it as pi d square divided by 4. So it is nothing but pi by 4, and what is the diameter? 1 into 10 power minus 2 the whole square. So simplifying this, we will get 7.85 into 10 power minus 5 meter square. Since it is area, the unit is meter square, should not forget. Now we have force, we have area. So force divided by area gives us pressure. Our task is to find the pressure exerted, that is P is equal to F divided by A. F is 490, A is 7.85 into 10 power minus 5, and we will get 6.24 into 10 power 6 Pascal is the pressure exerted by the heel on the horizontal floor. Next we have Torricellis barometer use mercury, Pascal duplicated it using a French wine of density 948 kg per meter cube. Determine the height of the wine column for normal atmospheric pressure. So we have to determine the height of the wine column for normal atmospheric pressure. So normal atmospheric pressure is nothing but the value P is equal to 1.013 into 10 power 5 Pascal. So how to find the height of the liquid column? So from the formula P is equal to H rho G, we can write H is equal to P divided by rho into G, where P is 1.013 into 10 power 5 divided by the value of rho, density is given, so it is 948 kg per meter cube. So 948 into value of G is 9.8. So simplifying this, we will get the height of the wine column, that is H is equal to 10.90 meter. These are few numerical examples from the chapter Mechanical Properties of Fluids. You have to try the different problems from the textbook or any reference books, and so that you will get the ability to solve many numericals. So this completes the chapter Mechanical Properties of Fluids. In the next session, we will discuss another new chapter. Until then, take care all of you. Thank you.